Assalamualaikum. Today we are here with another video, how to detect outliers using different tests. I'm using the same data which I have used in previous video, where I have 5 variables. Operational self-sufficiency is my dependent variable and rest 5 of the variables are my independent variable. Then you need to go to this data and import the Excel file. And then click OK, right? First I'll introduce the tests with you that I'm going to use. The first test I'm going to use is leverage test. Leverage method is to identify the observations that will have a potential great influence on regression coefficient estimates, right? So a leverage greater than this formula, where the k is the number of variables, independent variables, and n is the total number of observations in your data set. Let's process it in on this data. For this, the command is, you need to firstly process the regression of your model, where in my case it is regression, dependent variable of operational self-sufficiency, and rest of the 4 independent variables. Click enter. Then the command for analyzing the leverage test is predict LEV, leverage. Here a new variable will be generated of leverage. Then you need to display this number, which is basically the formula of 2k. K in our case is 4 independent variables, plus 2 divided by 55. 55 is our observation of operational self-sufficiency. Press enter, and here a number have been generated. You need to simply copy this and generate the next command, which is list operational self-sufficiency, and then your independent variables. If leverage is greater than this value, the outliers will be shown. Press enter, and here you can see that these are the extreme values: 4th observation, 31st observation, and 44th observation, which is basically the outliers in our case. This command shows that if the values is greater than this that we just calculated, then these are the outliers in our data. Let's move on to other test, which is diffs test. The diffs method is another method to detect the influential values in the data. The cutoff point for this is 2 into square root of k divided by n. K is the number of variables and n is the number of observations, as I have mentioned earlier. Diffs can be either positive or negative, with numbers close to 0 corresponding to the points with the smaller 0 influence, right? So let's process it on data. For this, the command is predict diffs, diffs. Predict dift, diffs. And then you need to again display this list, which is basically list your dependent variable and all your independent variable. If ABS bracket dift is greater than 2 square root of 4 divided by 55, 4 are the number of independent variables, 55 is the number of observations. Press enter. Here you can see that these points are the extreme and outlier values in our data set of all variables. You don't need to just analyze a single variable. These tests provide you the extreme values in all your data sets, all your data points and variables, right? So this shows that 4, 31, 37, 44, 46 and 49 are the outliers in the data. You can see over here as well that 3 of these values are same from the previous test. Let's move on to the other test, that is DF beta test. DF beta is the specific measure of influence that assess how each coefficient is changed by deleting the observation. this command is run and created for each predictor in the model. So a df beta value in excess of 2 divided by square root of n merits for further investigation. Let's test it on the stata. For this, the command is df beta, and it will create the df betas of all the independent variables. You can see that all the independent df beta variables have been generated. Next, you need to list them out. For this, the command is list and select all the newly df beta generated variables and press enter. Here all the df beta generated commands and variables results are being processed. Then you need to display its value, its excess value, right, to investigate whether the values are greater or not. Here you can see that this display value has been generated. You will then again need to add the scatter. You need to make a scatter plot where the command is scatter. Select all the df beta generated variables, comma y label -1 into 0.5 into 3. This is the basic value of this df beta. Then y line, in y line you need to add this displayed value for positive and for negative as well. Here a graph will be generated, and you can see that these data points are the outliers in the data set. But how can you identify that which ID is the outlier in this case? For this, the command is scatter, the same command, and then you need to add m label bracket ID. You need to add multiple of time ID, because the greater you have the number of variables, the more you need to add ID in this command. Since I have 4 variables, so I am adding 4 times ID, and it will show the, oh sorry, we haven't generated the ID variable. For this you need to generate gen ID is equals to underscore n, and then you need to reprocess this command. And here you can see that now against each variable that the color is now shown, right? So each variable, you can see the outlier of each variable. Let's say the debt to equity df beta extreme value for is 4, which is represents by green, 31, 49. Same is the case with assets and the capital asset ratio, right? Let's move on to another method, another test, which is age test. This test checks the fluctuations in the independent variable. The command to process is predict age, lev, which I'll show you in stata. This test tells whether the functional form is correct or not, which is used in the data. The interpretation for this test is that if the value is increased by 0.5, then we'll say that this value is an outlier in the dependent variable or in any variable. We can check it by sorting, but if the data is large, then it is easy to predict it through command. Let's check it out in stata. For this, you need to again process your model, which is regression dependent and then independent variables. Next, you need to add a command predict age, lev, press enter, and here the h variable, that is the leverage variable, have been generated. Next, you need to list out the values that are in excess of 0.5 that I have just mentioned in slide, and here you can see that only 31 observation is in excess of 0.5, which means this is the extreme value in the data set. And here you can see the results of previous test as well, which is the leverage, depths, df beta, age as well, right? Let's move on to another test, which is our student test or studentized residuals. Studentized residuals are used to analyze the outliers in the regression model. This test will check the fluctuation in the error term. The absolute value of residuals is 2, which is -2 and till +2. If that exceeds this range, that means it is an outlier in the data. Let's check it out in the data. For this, the command we again need to process the regression, and then the command for it is predict r, r student. Press enter, and here another variable have been generated, that is r, studentized residuals. Then you need to list out if the value of r is greater than 2 and -2, lesser than -2 and greater than +2. And here you can see lesser than -2, 37 shows that this is the outlier, where the operational self-sufficiency value of -0.0981 is an outlier in the data set. And +2, 46, 48 and 49 observations is the outlier in the data set. Here you can see that all the previous results are also shown in this table as well. Now let's move on to another method, which is the distance test or Cook's D test. Cook's D test is another method of detecting the overall measure of influence. The lowest value that Cook's D can assume is 0, and the higher Cook's D is the most influential point. The Cook's D test provides the combined effect, so we have to check whether the result of distance test affect the dependent variable, then we have to treat it, otherwise we can leave the outlier as it is. The convention cutoff point is 4 divided by n. N is the number of observation. We can list any observation above the cutoff point by doing the following. Let's move on to Stata to analyze this. For this, the command is predict r Cook's D, right? Predict D, Cook's D, press enter, and here the D has been generated for Cook's D test. Then you need to list if D is greater than 4 divided by 55. 4 is the estimated value and 5 divided by 55 is the number of observation. 4 is the edited value which you cannot change, right? Press enter, and here you can see that 4, 31, 49 are the extreme values and outliers in the data set according to all the tests we have used, right? Like from leverage, from diff, from DF betas, from H, from R, and from D tests, right? So this provides the overall conclusion of all the results of all the tests we have used, and this provides the summary of all the tests. Like on the basis of all the tests, these 3 are the extreme and outliers in our data set. You can further, since the value of analysis can be a little tricky for you, so I have made a summary analysis over here where you can see that the criteria for analyzing each test is given in this table, which I have shown you on Stata as well. Thank you and Allah Hafiz.